Alright, this is section 4.6, which is on the quadratic formula. So I think it's helpful with these problems to, first of all, just have the formula written somewhere where you can easily locate it. And again, this applies only to equations that are in standard form. So before we do either of these problems, we have to put these equations in standard form, which means that they are equal to 0. So that right there is standard form. So the first thing we need to do would be to move this 3n over, so that it's now in standard form. We would have n squared minus 3n plus 8 equals 0. Now it's in standard form. Now we can use the formula. Just to help us out, I would recommend writing down next to this your a, b, and c. So a is the number in front of this squared term, and here a is 1. So a equals 1. Second number right here is b, and b is this number right here, so that's negative 3. And the third and final number would be c. C is the constant term, it's the term by itself. So once you have a, b, and c, it's easy to plug them into that formula at the top. Negative b plus or minus. Let me put this kind of as an outline. We'll just fill in what we need. So negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2a. And just to mention, that's everything is over 2a, not just the square root part. That's important because if you leave out, if you don't divide everything by 2a, you'll get what turns out to be a different number. So negative b, b is negative 3, so negative 3 plus or minus b squared minus 4 times a, and a equals 1, times c, and c is equal to 8. Once we have this, all we need to do is just simplify that down. So we will keep going from there. Negative 3 is positive 3 plus or minus the square root. Negative 3 squared is 9, and then this thing right here turns out to be, well, negative 4 times 1 is negative 4. Negative 4 times 8 is minus 32, and that's all over 2 times 1, or all over 2. We can keep simplifying this a little bit more, so 3 plus or minus this number under the square root is negative 23. And then because we have a negative square root, we're going to have an imaginary number. So this is going to be 3 over 2. All I'm doing here is just splitting this down the middle and putting each thing over its own number, just to make it a little bit easier to work with. Negative 23, the square root of negative 23, the first thing we want to do there is pull out a negative 1, and pull out an I. So you could rewrite that as the square root of negative 1, which is I, times root 23, and that would be the final answer. 3 over 2 plus or minus I root 23, and that's all over 2, and that's the answer. It's an imaginary number. Alright, this top one right here, very similar problem. We just need to put that in standard form by adding this. So we'll have negative 5n squared minus 2n plus 1, and that's equal to 0. Okay, then we will use some different colors for a, b, and c. So a is equal to this number, negative 5. Okay, b is going to be this middle number, which is negative 2. And finally, c is going to be this constant term right here, which is positive 1. So now that we have our a, b, and c, we can plug those things into the formula. So negative b plus or minus the square root of b squared minus 4 times a times c, that's all over 2 times a. We'll just fill in what we need to fill in. So b is negative 2, which b goes here and it goes here. A is equal to negative 5, and a goes there and there. And then finally c is equal to positive 1, which goes right here. Now we can simplify all this. So that's what we'll do. So let's take this. So negative 2 is positive 2 plus or minus. Negative 2 squared is 4. This part right here, notice it's negative 4 times negative 5, which is positive 20, times 1 is still positive 20. And then the bottom is 2 times negative 5, which is negative 10. We'll simplify that just a little bit more. Just to make this easier, we'll split it down the middle again. So we'll have 2 over negative 10, which is negative 1/5, plus or minus the square root of 24 over negative 10. Now the square root of 24 again is something that we can simplify like we did before. We want to look for a perfect square that comes out at 24, and that would be the number 4. 4 times square root of 4 times square root of 6 equals 24. Square root of 4, that's equal to 2, so that's the same thing as 2 root 6. So this whole thing, put it down here, this whole thing could be 2 square root of 6 over negative 10. And then the very last thing we can do, because 2 and 10 both have a common factor of 2, 2 goes into itself once, and it goes into that number negative 5 times. So the final answer would be negative 1/5 plus or minus the square root of 6 over negative 5. And if you want, you could put all of that over 5. Now here's the thing, even though that's a negative 5, notice that it's going to get a plus and a minus, so you really, it doesn't matter if that bottom part is negative or positive 5, at least for the second part of this answer. So you can either leave it like we just wrote, or you could write negative 1 plus or minus root 6, and that's all over 5. Okay, this part of the quadratic formula, the part underneath the square root, is called the discriminant, b squared minus 4ac. Just this thing, not the square root itself, but the b squared minus 4ac. What that tells us is how many solutions an equation is going to have. So if that number is positive, you'll have two solutions. You're going to have one of them coming from plus that discriminant, the other one will come from minus that discriminant. If that equals 0, you're just going to have one solution. Like pretend that was the number 8, you'd have plus 8, or sorry, pretend this negative b was the number 8, you'd have 8 plus 0, and you'd have 8 minus 0. Well, that's the exact same number, so you only have one solution in that case. And then if the discriminant is negative, you have no real solutions, because you can't take the square root of the negative and get real solutions. You will have two imaginary solutions, though. So let's calculate the discriminant for both of these. Let's start with this first one right here. That's a right there. B is 8, and c is 4. So b squared would be 8 squared minus 4 times a is 5 times c is 4. This turns out to be 64 minus 4 times 5 is 20, and 20 times 8 is, 20 times 4 is 80. 64 minus 80 is negative 16. Since that's a negative number, you'll have no real solutions. So this one is wrong, and so is this one. You will have two imaginary solutions. So we'll go with option A right there. Okay, this one right here, a is equal to 9. There's the a. There is no b, because b is the number in front of x, and you can see up there there's no x term. So if there's no x term, then b would be 0. This would be a strange way to write it, but you could write this as 9x squared plus 0x minus 9. And then finally c is this last number, so c is negative 9. So at this point we have our quadratic formula. We have b squared, so 0 squared minus 4 times a is 9 times c is negative 9. That becomes 0. Negative 4 times 9 is negative 36. Negative 36 times negative 9 would be positive 324. So the discriminant is 324. That's a positive number. And that means this one and this one are wrong. If you have a positive number, it's going to be negative b plus the square root of that, negative b minus the square root of that. That gives us two solutions. So that would be option D. 4.7 is on something called writing an equation in vertex form. And vertex form looks like this right here. Okay, this number here is the x coordinate of the vertex, and this number here turns out to be the y coordinate of the vertex. Okay, so first thing is on 28, that's not going to factor, so we don't want to deal with the negative 58, so we're just going to kind of move it off to its own on the side. This is exactly like completing the square. The only difference is instead of, normally we would move that minus 58 over to the other side, we're just going to keep it on this side and not do much else with it. Then we look at these two numbers right here, and we can factor out a negative 4. Because if you remember from before, completing the square only works when the number in front of x squared is 1. If it's not 1, we need to make it 1 by factoring out that negative 4. Okay, if you divide this by negative 4, you just get x squared. If you divide that by negative 4, 32 actually, you get minus 8x. And now in the parentheses, we're in a position to be able to complete the square. So we would take half of this number, which is negative 4, and then we would square negative 4 to get 16. So 16 goes right here. Now normally we would balance out whatever we did on the right side by adding that to the left. Again, we want to keep everything on the right side. So here's what you have to think about. Even though it looks like you added 16, you didn't. You actually added 16 times that negative 4. 16 times negative 4, that's negative 64. So it's really like you just subtracted 64. And what I tell people is, think about it this way. If you stole $64 and you want to balance that out, what would you do? If you stole 64, if you minus 64, you would balance that by adding back 64. So what that does is that now balances the whole right side. We subtracted 64, but then we added it right back, and that's why it's still balanced. Okay. So now we can simplify this a little bit more. So we have y equals, we still have that negative 4. In parentheses, this thing is a perfect square. It's x minus 4, the whole thing squared. Again, where did the minus 4 come from? It was half of negative 8, so that's how we factor it. And negative 58 plus 64 is positive 6. This is now in vertex form. If you look back at our original up here, that's what vertex form looks like. They didn't ask us for the vertex, but let's just find it anyway. And by the way, this negative 4 tells us the parabola opened downwards like that. Okay, how do you find the vertex? You look and see what x value would make the parentheses 0, and that would be 4. And then this number right here, if this whole thing equals 0, then 0 plus 6 would be positive 6. So there is the vertex of that parabola. Okay, so the way I tell people to remember this stuff when you're transforming parabolas is a simple kind of acronym. Add to x, that means you're going left, and then add to y means you're going high, you're moving the parabola up or down. So if we look at 29, g of x takes f of x, it takes x squared, it does 4 things to it. First of all, the minus 3. We say over here, add to x, go left. We're not adding to x, we're subtracting from x. If we add to x, go left, that means subtract from x would be going right. So this right here means go right 3. So this one is wrong. That doesn't say right 3. That doesn't say right 3. Actually, the only one that says right 3 is D. Okay, supposing that several of the other ones had said right 3, we have to keep going. So this 1/3, that tells us if we will vertically stretch or shrink it. And since that number 1/3 is smaller than 1, it's going to vertically shrink or vertically compress it. If you think about this though, if you vertically stretch something, if you have, some, let's say a box, and you kind of start stretching it out so it becomes like this, it's not a great picture, but the horizontal width, if you vertically stretch it out horizontally, you would shrink it, and vice versa. If we vertically compress something, so we take this right here and we compress it down, well, now it gets wider, now it horizontally expands. So that's why option D says compress vertically, because we're multiplying by 1/3. That means we're shrinking it. Okay, the negative has nothing to do with vertical stretch and vertical shrink. The negative just tells us whether it's going to open up or down. And if I have a parabola that opens up and I suddenly make a negative, now it opens down. Because it opens down, that has the effect of flipping it over the x-axis. So that's what that one means right there. And then finally, add to y, go high. So that means we're going up 3. We're adding to y. And that's what that says right there. Translate up 3. Alright, we'll take a look at 30. So on 30, again, we have 4 things. This right here means go right 1. This right here means we're going to vertically do something to it. But if you look at these options, none of these have, these say expand vertically by a factor of 3. But notice this is not really 3, this is actually 3 being squared, so that's like a vertical expansion by 9. If you vertically expand something, that means you're going to horizontally shrink it, or horizontally compress it, so this one may be an option right here. Okay, here you're not actually expanding by 3. The negative is going to flip it over the x-axis, not the y-axis, so that's wrong. And then this right here will go up 1, add to y, go high, so let's see which of these options we have. We know we're going right 1, so that's wrong. This one is still a possibility because that has right 1, and so does that. Reflect across the x-axis, they both have that. Translate up 1, they both have that. So the only difference is expand vertically by 3, compress horizontally by 3. Well, again, we're not expanding vertically by 3 because this is not a 3 right here, that's a 3 squared. So you're actually vertically expanding by 9. So that's why D is wrong. That leaves us with option A. We're compressing by 3. because vertical and horizontal do opposite things. If you're vertically stretching, you're horizontally compressing. Alright, last two problems from 4.8, we want to sketch the graph. And we can either put that in vertex form like we did before, or we can use this formula for the vertex. The vertex is negative b over 2a. So if you look at this, a equals negative 2, b equals negative 4, and c equals positive 2. So negative b over 2a, that would be negative negative 4, which is positive 4, over 2 times negative 2, and that's negative 4. So the vertex will occur at negative 1. So let's make a table of values so we can kind of see where we're going to graph this. So we'll put negative 1 in the middle. And after this, we will put a couple numbers bigger and smaller. So bigger than negative 1 would be 0, smaller than negative 1 would be negative 2. The way that we get the y values is we use that equation they gave us. So y is, and for this one I'll just say equals to, when we graph it we'll talk about what the greater than means. So if you plug these numbers in, negative 2 times negative 1 squared minus 4 times negative 1 plus 2. Okay, what is that going to be? Negative 1 squared is 1 times negative 2 is negative 2. That's going to be plus 4, which is 2. Plus 2 is 4. And then these, when you plug them in, they both turn out to be 2. So let's graph that. Negative 1, 4 puts us here. By the way, because this number in front is negative 2, it's going to open down. So let's make sure we have the right picture there. There's 0, 2. There's negative 2, 2. Okay, this is the next important part with inequalities. This right here means that our line will be solid because y is both less than and it could be equal to that. If it had just said less than, we would have a dotted line. And then this kind of splits it into two regions. You have region A, which is the stuff above. Region B is the stuff below. That says y is less than this line. So less than means you shade all this stuff. If you're not sure that you shaded in the right place, what you can do is test a point right here, let's say, and plug it in and see if it works. So that's the point negative 4, 0. If we plug that into our original equation, let's test it, we would have y equals 0. Is 0 less than or equal to what I get when I plug in negative 4 for all this stuff? And when we do plug all this stuff in, that's going to be negative 32 plus 16 plus 2. That turns out to be negative 14. 0 is not less than negative 14, so we would know that if we had shaded where the yellow dot is, we'd have the wrong place of shading. Last one is solve this same type of inequality. Now we're going to solve it by using what are called test points. So first step is always put this in standard form, which we will. So we have x squared plus 2x minus 35, and that is greater than or equal to 0. We can now factor this. We're looking for numbers that multiply to negative 35 and add to positive 2. Since this is negative, I know that one of these will be positive, one will be negative. And the numbers that do that are positive 7 times negative 5. That equals negative 35. Positive 7 minus 5 equals positive 2. So if we wanted to solve this, we say what x value makes this parentheses 0, and it's negative 7. What x value makes that parentheses 0, it's x equals 5. What does it mean to use test points? It means to, that's what the problem said. Let me scroll up a second. It says solve this using test points. It means put these two numbers that we just found on a number line. Should we shade or not shade those circles? Well, this says we're greater than or equal to, so that means we would shade those in right there. And then the next thing we need to do is we need to kind of divide this up into 3 regions. Okay, so here's our 3 regions. We'll call this R1 for region 1, R2 for region 2, R3 for region 3. And we're going to test points. So let's test something that's in region 1. Anything to the left of negative 7, we'll try negative 8. Let's plug in negative 8 to this equation. So if I plug in negative 8 right here, I'd have negative 8 plus 7. That's a negative number. Then if I plug it in here, I'd have negative 8 minus 5. That's also a negative number. A negative times a negative is a positive number. So that means any number at all that you plug in from region 1, could be negative 8, could be anything else, you're going to get a positive number when you finally plug it into inequality. Region 2, any number between negative 7 and 5 would be in region 2, so let's just take 0. If you plug in 0 right here, you'd have 0 plus 7, and that's a positive number. You plug in 0 here, 0 minus 5, that's a negative number. A positive times a negative is a negative. And that will hold for anything in that region. Region 3, anything bigger than 5, let's try 6. You plug in 6 right here, 6 plus 3, that's positive. You plug in 6 right here, 6 minus 5 is also positive. A positive times a positive remains a positive. So now let's go back to our original. It says that this is supposed to be greater than 0. Well, greater than 0 means it's positive. So that means we're in this region right here, because we said before that those are positive. And we're in this region right here because that stuff is positive. So how do you write your final answer? Here's how you write it. You would say, just change colors here, you would say x could be anything in this zone, so x is less than or equal to negative 7, or if you're in this region, x is greater than or equal to positive 5, and that would be our final solution for solving that inequality.